Restarting. Hey guys, got section 4.3 today. We are going to talk about logarithmic functions and their applications. So first off, let's look at the review. Everybody's got their notes brought up. On the review, we want to find the inverse of this function. F of x equals 2x over x plus 3. And if we remember correctly, when we're finding the inverse, we're going to change from f of x to y. And then we want to switch the x's and the y's. So that becomes x equals 2y over y plus 3, right? And we would go ahead and we would solve this equation for y. Now, when we have an exponential function, we want to find the inverse of that, we would do the same thing. We would have y equals b to the x, and we want to try and solve this. We change the x's to y's and the y's to x's, but now we want to change that and solve that equation for y. But it's hard to do to get that y variable out of the exponent. So the only way that we can do that is by using a logarithmic function. And a logarithm with a base of b looks like this. Y equals log base b of x. Now, if we refer back to our notes, we know that the base is going to be the little number underneath the logarithm. These are equivalent expressions. This is the exponential form, and this is the log form. And you can interchange back and forth between those two forms. Now, if I have this expression, the log base 4 of 64 equals -3, and I want to rewrite it in exponential form. The easiest way we do this is with a little loop. I'm going to start with the base of the logarithm, and I'm going to loop around the equals, and I'm going to end up with the argument of the logarithm. So, this is my 1, this is my 2, and this is my 3. So I always start at 1, I'm going to have 4. That's going to be the base of the exponential expression. I'm going to go past the -3, so that's my exponent. That's going to equal my ending result of 64. So I get 4 to the -3 equals 64. This is the exponential form. This is the log form. They are equivalent. Okay, let's try the next one. It's the log base 5 of x equals 3. Yep. Okay, so we want to change this from log form. We want to write it in exponential form. So I'm going to do the loop just like I did before. So I start with my base, which is a 5. I go past the 3. That's going to be my exponent, and it's going to equal the x. Exponential form, equivalent, log form. And we can also go the other direction. So if I start in exponential form, on my next example we have 2 to the 5th equals 32. So this would be the exponential form. And I want to change it to the equivalent log form. So I can do a loop just like I did before. I'm going to start with the base of the exponential. I'm going to go around the equals. I'm going to end up at the exponent. So I know I'm going to change to log form, so I have to start with log. So I have log with a base of 2. There's my 1. I went past the 32, so that's my next number I put in there. And it's going to equal the exponent. Anytime you have a logarithm, it always equals to the exponent in the exponential form. Okay, let's try the last one. The last one is 10 to the second power equals 100. there's my exponential form. I want to rewrite this in logarithmic form. So I get log with a base of 10 of 100 is equal to 2. There is my loop. Okay, I ended up at the exponent. That's my answer. Okay, we have some basic properties. We had b to the log base b of x is equal to x. Find a different marker. So anytime we have an exponential expression, I know I have an exponential expression because I have a variable in the exponent. The logarithm happens to be in the exponent, but the bases of both of those parts are the same. They're going to cancel each other out, and our answer is just going to be x. The next property is log base b of b to the x. That, again, is going to equal x. So, again, base and base here are the same numbers. When those occur, they cancel. My answer is just going to be the exponent. Log base b of b. Okay, in this case, my exponent is not an x. My exponent is just a 1. So those would cancel each other out. It still just equals the exponent, which is just 1. And then the last one, the log base b of 1. Is equal to 0. Does not matter what the base is. If the argument of the logarithm is 1, it's always going to simplify to just give you 0. So we want to evaluate these expressions. The log base 6 of 1296. And it says without using a calculator. So what I want to do is I want to rewrite 1296 as 6 to a power. Because if I can get both parts, both bases written the same way, I know that they're going to cancel. So 1296 is 6 times, this will be 2, was that 1, 6, and then 6 and 36, and then 6 and 6. So I have 6 to the 4th is 1296. So now the base and the base are the same. I know this answer is just going to be 4. You can do this on your calculator. So on your calculator, if you go to your math button and then go down to the option that says log base, it will let you put in a base that is different than the 2 buttons on your calculator. But you can evaluate any logarithm that way. Now, the graph, stop it.